Hi everyone, it's Miss Berry. In this video, we are going to go over the problem solving lesson in Unit 1. So I'm just going to start by showing you the NCTM's process standard for problem solving. I'll let you read it if you want to pause the video and read it, and then I'm just going to highlight some of the more important parts. All right, so problem solving is not only a goal of learning mathematics, but also a major means of doing so. It's an integral part of mathematics. It's woven throughout everything that we do. It's not just a single section that we cover and we never go back and talk about problem solving again, or we never go back and use problem solving again. So this is going to be an integral piece of what your students are learning, and it should be woven throughout the school year. Students need frequent opportunities to struggle with problem solving, and it's okay for them to struggle, and in fact they need to see these complex problems that involve a significant amount of effort. So it is okay to let them constructively struggle. They're encouraged to reflect on their thinking throughout the problem solving process and at the end of the problem solving process, so that whenever they see a similar problem, they can say, okay, well, I know that was not the right technique to use. I know that in the future, this is how I would go about solving this problem. All right, so let's talk about the problem solving process. So we're going to talk about George Polya's four-step problem-solving process. George Polya was a Hungarian American mathematician. He was born in Hungary and moved to America. He worked at Stanford University, and he made significant contributions to the field of problem solving, as well as lots of other fields in mathematics. But his four-step problem-solving process is really widely known, very popular among mathematicians. And he wrote a book called How to Solve It. And in this book, he gives a lot of kind of fun puzzle type problems, and he lays out kind of a general, process, step-by-step instructions, very general instructions for how to approach complex mathematical problems. All right, so this is our four-step process. The first step is to understand the problem. Step 2 is to devise a plan. Step 3 is to carry out the plan. And then step 4 is to look back and reflect. All right, so understand the problem, devise a plan, carry out the plan, and then look back. All right, so anytime we're talking about these problem solving in this section specifically, we're going to be talking about word problems. So you want to start by really understanding, what is it here that they're asking me for? What am I supposed to be finding out? Is there any information that they've given me that I don't need? Is there any information that I feel like I need but I don't have? So you're going to read the problem carefully, identify any context clues. If there's a word that you see that you don't recognize, you're going to look that word up. Maybe this might be the point where you highlight part of the problem, highlight the important parts. Step 2 is going to be to devise a plan, right? So you might decide if you're going to approach this problem from a visual standpoint, or maybe you're going to go at it algebraically, or maybe you're going to draw some kind of picture, or maybe you're just going to plug in some numbers and try something. You might name your variables at this stage. So if there's more than one thing that you don't know, you might say, okay, I'm going to let X be this, I'm going to let Y be this. And you might just do some guessing at this stage. So you might say, okay, well, I feel like, it can't be more than 100, or it can't be less than 2. Right? So you might just pick some numbers and guess and test. All right, so once you've come up with a plan, then you're going to carry out that plan. As you carry out the plan, you may have to modify your plan. You may say, okay, this definitely didn't work. I'm going to go back to step 2 and come up with a different plan. Right, so you're going to carry out the plan, which may involve some sort of modification or a change in approach. And then after you have carried out the plan, you are going to look back, you're going to check your work, you're going to go back and acknowledge and fix your mistakes, and then reflect. So you might say, okay, well, you know, the first way that I tried doing this, it didn't really work out, but here's what I had to do differently, and that fixed it. Okay, so let's apply Poya's 4-step problem-solving process in some actual problems. All right, so here's our first problem-solving question from the notes. It says, solve the magic square puzzle. The sum of each row, column, and diagonal must be the same. The magic number is 15. So each row, column, and diagonal is supposed to add to 15. All right, so the first thing I'm doing in Poya's 4-step process is I'm just understanding the problem. So I might go through here and say, okay, I see the word sum, right? So that tells me I'm going to be adding, right? I see the words row, column, and diagonal. So that's where it's going to tell me to look. All right, so let's take a look at our rows, columns, and diagonals. All right, our first row, we've got just a 7. Our second row, we've got 9 and 1. So we've got a little more information in that middle row. And then the bottom row, we've just got a 3. For our columns, our column on the left, we've just got a 9. Our column in the middle, we've got 7 and 3. So again, a little bit more information in that middle column. And then on the right column, we've got just 1. Right, and then our diagonals are both blank. Right, so both diagonals are completely empty. So those aren't very helpful. All right, and then the last sentence says that the magic number is 15. All right, so that's what I'm sort of keeping in mind here. The magic number is 15. All right, so now that we understand the problem, we're going to devise a plan. All right, so whenever we were just reading through the problem, when we were looking carefully at the magic square, we noticed that the middle row and the middle column both had the most information. All right, so that should be where we start, I think. All right, so our plan is going to be that we're going to either start in the middle row or the middle column, because that's where I have the maximum amount of information. All right, so let's carry out the plan. All right, so let's carry out our plan. I'm going to start with the middle row. If you want to start with the middle column, that's totally fine. All right, so I'm looking at the middle row, and I know that this is supposed to add to 15. So right now I've got 9 and 1. 9 plus 1 is 10. So what would be the middle number if it has to add to 15? It would be 5, right? Okay, so let's check and make sure that our middle column adds to 15. 7 plus 5 is 12, plus 3 is 15. Perfect. All right, so now we can move on. We know that our diagonals are supposed to add to 15. Our columns are supposed to add to 15, and our rows are supposed to add to 15. At this point, it really, I think our best approach here would just be to try to do like a guess and check situation. So I'm gonna go with the left column. There's no rhyme or reason to that. You could have went with the top column. You could have went with the top row. You could have went with the diagonal. I'm just picking the left column because it's right there. Also, I think that since the number 9 is a pretty big number, that's going to limit our options for what can add to 15 in that column. So that is another more maybe like logical reason why we might pick this column. All right, so if we have 9 in the middle and we need the whole column to add to 15. Let's see, 9 plus 6 is 15. So this top square and the bottom square need to add to 6. What are some numbers that add to 6? 5 and 1. We can't use those because those are already used right here. All right, 6. 3 and 3. Can't use that. 3 is already used right here. 4 and 2. All right, 4 and 2, let's do that. I'm going to put the 2 up top because it's smaller, because we've got another kind of big number up here, 7. All right, so I'm going to put the 2 up top, and I'm going to put the 4 at the bottom just because, you know, I don't want to go over 15. So I feel like if I put the 4 up here, that's already 11. So I would need 4 more to add to 15. So that, yeah, that definitely wouldn't work if I had 4 in the top. So let's put 2 in the top, 4 in the bottom. Okay. Now let's check and make sure we're good. All right, so looking at this column, 9 plus 2 is 11, plus 4 is 15. Okay, that's good. We already know that this column, middle column adds to 15. Now, we just need the diagonals to add to 15, and then this column over here to add to 15, and the rows, of course. All right, so you can use any approach here. If you can fill in the top square, the bottom square, it doesn't matter. I'm going to fill in the bottom square. All right, so I'm looking at this bottom row. 4 plus 3 is 7. I would need 8 there to make that add to 15. All right, so I haven't used 8 yet, so that's okay. Each number can only be used once. And that's going to leave 9. No, I've already used 9 right here. What number am I missing? 1, 2, 3, 4, 5, 6. All right, so I'm going to need 6 up here. So let's make sure that's going to work. Let's check and make sure that 6 works. 8 plus 1 is 9, plus 6 is 15. That works. 6 plus 5 is 11, plus 4 is 15. So that diagonal works. And then 6 plus 7 is 13, plus 2 is 15. So that works. All right, so let's reflect on what we did there. Well, first of all, we have checked our work. We're looking back. We've checked our work. We didn't have any mistakes. That was just a lucky, you know, that's the way it worked out this time. Every once in a while when you're doing these magic squares, you might put the number in the wrong spot. So imagine at first if we had put 4 here and 2 at the bottom, that would have been a mistake, and you could have just switched them and then tried it that way. Excuse me. But we did not make any mistakes this time. And then just reflecting back on what the big idea was here was you wanted to start with the row or the column where you had the most information, or the diagonal if you had, you know, 2 numbers in a diagonal. Each number could only be used once, so we were just keeping that in mind when we were choosing our numbers. And whenever we did only have options where we only had 1 number in a row, 1 number in a column, 1 number in a diagonal, we were going with the option that had the largest number, because that's going to limit what your other 2 numbers can be. All right, so let's look at our next problem-solving question. So let's take a look at our next question. Sorry if I just said that twice. The recording messed up and I had to start over. Okay, so the second question says, the sum of 3 consecutive integers is 159. Find the integers. All right, so we're going to use Polya's 4-step problem-solving process to solve this. First step is to understand the problem. So let's go through word by word here. The sum, so we're adding. The sum of 3 consecutive integers is 159. All right, so we have x plus y plus z equals 159. All right, so we have 3 different numbers. The 3 numbers in question, it says that they are supposed to be consecutive integers. So let's talk about what is a consecutive integer. Well, first of all, what is an integer? We know that an integer is going to be our positive and negative whole numbers and 0. And consecutive means one after the other. So an example of 3 consecutive integers would be 9, 10, and 11. All right, so 3 consecutive integers, that's just going to be 3 numbers that are one after the other. 9, 10, 11, 1, 2, 3, 100, 101, 102. Right, and we know that these 3 integers add to 159. All right, so we're supposed to find the integers. All right, so now that we understand the problem, let's devise a plan. I've just given you an example of 3 consecutive integers, so let's just use these as a sample problem. We'll see how big of a number does this give us, and that'll give us an idea of if we're even in the right range. All right, so 9 plus 10 plus 11. 9 plus 10 is 19, plus 11 is 30, right? Let me write that down. Okay. 9 plus 10 plus 11 is 30. Yeah, had to double check myself on that one. Okay. So we're not even close to 159. So these numbers have got to be much bigger, right? All right, so we are not even close to 159. So we could pick bigger numbers. We could, obviously they can't be bigger than 159 because it's got to be 3 of them and they got to add to 159. So you could pick like, maybe 40, 41, 42. And if that didn't work, try, 43, 44, 45. So you could really guess and check here. It's not, that wouldn't be wrong to do it that way. I'm going to go about it in a more algebraic way. All right, so I'm going to let the first consecutive integer be x. All right, so the next consecutive integer, I could call it y, or I could be more specific and I could say, well, it comes right after x, so it's got to be x plus 1. And the next one, it's 2 numbers after x, so it's got to be x plus 2. All right, so I'm calling the first consecutive integer x. My next one, it's got to be 1 after x, so it's x plus 1. And the next one has got to be 2 after x, so it's x plus 2. All right, so I'm going to add these together, and I'm going to set them equal to 159. All right, so now I'm going to just combine my like terms. X plus x plus x is 3x. 1 plus 2 is 3. All right, now I'm going to try to solve for x, so I'm going to subtract 3 from both sides. That's going to give me 156 on the right. Then I'm going to divide by 3 to get x by itself, which gives me 52. All right, so now I know what x is. All right, I know what x is. X is 52. All right, so that's the first consecutive integer. All right, so what comes right after 52? 53. What comes right after 53? 54. All right, so now grab your calculator, check and make sure that 52, 53, 54, when you add them together, they add to 159. Let's check together. 52 plus 53 plus 54. Yep, that adds to 159. So our 3 consecutive integers are 52, 53, and 54. All right, so this one, I know this one can be intimidating for people, but it really is not a terribly difficult problem. All right, so you could either use the approach that I used here, you could do this algebraically, or you could just guess and check. All right, so looking back, we did check our work. We checked that 52 plus 53 plus 54 was 159. We did not have any mistakes. And reflecting back, I think this was a super easy, quick way to solve this. I think the guessing and checking would take a little bit longer. But again, that is a totally fine way to solve this problem. All right, here we are at everybody's favorite type of problem. These seem to be the ones that people prefer. Right, it says use the clues on the left to solve the equations on the right. All right, so here's our clues. Let me switch to my laser pointer. All right, so our first line of our clue says triangle plus triangle equals 6. And then circle plus square equals 8. Okay. Triangle plus circle equals 4. And then square plus rhombus or diamond equals 10. Okay. All right, so where do you think we should start? So we've got to figure out what the value of these shapes are. Where do you think we should start? Is there a particular clue that you think we should start with? Hopefully you noticed that the first clue was the only one that had two of the same shape. Right, so if we've got two of the same shape that add to 6, the shapes have to be, you know, a triangle is equal to a triangle, right? So that means that 2 triangles equals 6. That means each triangle must equal 3. All right, and then now that we know that the triangle is 3, let's go down to clue 3 down here, and let's say, okay, well, triangle is 3. So 3 plus circle equals 4. So what is circle equal to? Right, circle is 1. Okay, so let's fill that in on clue 2. So circle is 1. 1 plus square equals 8. So up until now, you may have been thinking like, oh, it's the number of sides or something like that, but this kind of throws us off. So square is equal to 7. Square is equal to 7. So let's fill that in clue 4. 7 plus rhombus equals 10. All right, so rhombus must be 3. All right, so we now know the value of all the shapes, so we can go and plug them in to our little equations. All right, so as you can see, I have filled in the values for each of our shapes, and now we can go about solving. I want to advise you to look carefully at the operations here, because sometimes you can get in the habit of like only doing addition or only doing multiplication or something, and then sometimes they'll throw in a different sign. But as you notice here, all of these are addition. All right, so just looking at the operations here, all of these are addition. All right, so we're going to just go straight forward. 3 plus 7 plus 3 is 13. All right, the next line, 1 plus 7 plus 3 is 11. The next line, 7 plus 7 is 14, plus 3 is 17. All right, and then the last line, 3 plus 7 is 10, plus 3 is 13, plus 1 is 14. All right, so once we noticed that the first clue had 2 triangles, it was actually, the problem was pretty easy from there. All right, so reflecting back, we if you want to go back through and check your work, you can. If you want to go back through the clues one more time and check your work, you can. We did not make any mistakes. Reflecting back, I think again that the key there was just noticing that one of those clues had the same shape twice. Okay, I love this problem. I took this problem from our quantitative reasoning class that we teach here at CCGA. It says, a survey of 130 college freshmen at a local university produced the results below. How many students took only psychology? All right, so we've got a lot of information over here. I'm going to switch to a laser pointer. I did not mean to go ahead and pull up that Venn diagram, but we'll talk about that in a minute. So right now I'm just looking at the information they gave me. So 25 students took history, 23 took science, 22 took psychology. 15 took history but not science, 10 took science and psychology, 11 took history and psychology, and 4 took all 3. All right, so you can take one class, you could take 2 of the classes, you could take all of the classes. All right, so you could take just one of the classes, just 2 of the classes, or you could take all of the classes. Now, I want to point out to you here, and I'm going to highlight this, but the question is asking how many students took only psychology. They're not asking you to fill in everything. They don't want to know everything. They only want to know how many students were taking only psychology. All right, so the maximum would be 22, right? because in total, only 22 took psychology. So we don't know how many of those were taking psychology and science, psychology and history, just psychology, or taking psychology and science and history. Right, so we're going to break this down using a Venn diagram. A Venn diagram is a perfect approach for this problem because there could be overlap. You know, you could have people that are taking one class, two classes, or all three of the classes. So since we do have the potential for overlap here, a Venn diagram is a great approach. All right, so I do need to start by labeling my Venn diagram. So I'm just going to use H, S, and P. So top left little bubble there is going to be for history. The top right bubble is going to be for science, and then the bottom bubble is for psychology. So that's the bubble that I'm kind of interested in. All right, so the people that took only psychology, let me switch to my laser pointer. Remember the question was asking how many students took only psychology. So the people that took only psychology, they're going to be over here in this part of the bubble. If you were in this part of the bubble, that means you took science and psychology. If you were over here in this part of the bubble, then that means you took history and psychology. If you're in the very middle part of the Venn diagram, that means you took all three. Okay, so let's start by filling in the most specific information, and then we'll work our way out of the Venn diagram. Okay, so 4 people took all three. All right, 4 people took all three, so put 4 people in the middle. All right, so 4 people are in the middle. All right, working our way up the list. It says that 11 people took history and psychology. All right, so 11 people took history and psychology. All right, so let's think about what is the overlap between history and psychology. There's the history bubble. There's the psychology bubble. The overlap, you can see it's right there in between. 4 is part of it. But here's the overlap right there, that little middle part. All right, so I've highlighted that there. So there's the overlap between history and psychology. 11 people are in that overlap. Well, we've already counted 4 of them right here. That's the 4 that took all 3. All right, so these 4 people that are in the middle, it is true that they took history and psychology. They just also took science. All right, so they are counted as part of this 11. All right, so we've got to figure out what goes in this little chunk of the bubble that's going to make this highlighted part add to 11. That would be 7, right? All right, so 7 people took just history and psychology. 4 people took all 3 subjects. So together, 7 plus 4 gives me 11 people that took history and psychology. All right. Excuse me. Moving on. The next lineup. 10 people took science and psychology. All right, there's the science bubble. There's the psychology bubble. Where's the overlap? That's our overlap, right? Cool. 10 people are in that overlap. We've already counted 4 of them in that middle chunk. So how many people are left over? 6, right? So 6 people are going to go right here in this little chunk. 6 plus 4 gives me 10 people in total that took science and psychology. Okay. Now you could go on. You could fill in this whole Venn diagram, but you don't have to. All right, so if you like this, if you want to fill in the whole Venn diagram, if you think this is fun, you go right ahead. But you don't have to, because the question was asking how many students took only psychology. So we've got everything filled in the psychology bubble except for the little chunk out here by itself, which is what we're looking for. All right, so let's take a look at that line. 22 people took psychology. That means everyone in the psychology bubble needs to add to 22. All right, please ignore the highlighted part. Apparently, I forgot to make that go away. All right, so everyone in the psychology bubble, in that black bubble, is supposed to add to 22. All right, so let's see, what do these numbers add to right now? 7 plus 4 is 11, plus 6 is 17. All right, so if we have 17 already accounted for, and there's 22 in total, how many people are left over? So 22 altogether, 17 people are already accounted for. 22 minus 17 gives me 5. All right, so 5 people took only psychology. That was the only class they took. Okay, so reflecting back. If you had done the whole problem at this point, you might reflect back and say, hey, I didn't actually need to fill in the whole Venn diagram. I only needed to fill in the psychology bubble. We recognized that beforehand, so we didn't have to, fill in everything. Reflecting back, I do think that this is a great approach. I've seen people do it, just in their head, which is totally fine. But I do like this approach. I think that it's very organized and neat, and just keeps all the information right there in front of you, so you don't have to keep up with it in your head. Okay, so that is my lecture on problem solving. Please look at the problem solving discussion post and reply. That'll have all the details with the due dates and the requirements in there. If you haven't posted in the discussion board yet, you need to make sure and do that by the due date. All right, thanks you guys. I'll see you in the next video.